Thank you, and hello, Brisbane. I'm so excited to be back here for my second YOW. Shout out to the person over there with the 2017 shirt. That was the year I was there. I will have a confession for you all, which is Brisbane is my favorite city. Sorry, Melbourne and Sydney. I love your outdoor spaces, so thank you for having me. Today, I'm going to be talking about a project that I worked on while I was at Netflix. I'm not currently there, so this talk does not represent the company. This is my own personal story. And I'm going to tell this story in two parts. The first part is about how data scientists at Netflix struggled to get their machine learning models into production, and how Metaflow helped them become far more productive. And the second part of the story is about the team that built Metaflow. I want to talk about how they made Metaflow a success and what I believe is the single most important factor that led to that success. If you are interested in improving how you build products, this portion of the talk will be for you. A brief history of my time at Netflix. I've actually had two first days there. The first one was back in 2008, when Netflix was a US-based DVD by mail subscription company. And they had this brand new feature that allowed you to instantly watch a subset of that content. I was hired to work on that feature. 10 years later, when I returned to Netflix, that feature was the product. Netflix had become a global subscription streaming service, and it had over 100 million members. But getting back to 2008, I was very much in this paradigm that I will call traditional software. And as an engineer, my job was to build a system that was valuable to the business, and I needed to make sure that that system ran reliably without human supervision and produced correct results. That system at the time happened to be the services behind the Netflix play button that did everything between movie metadata to DRM licensing. I'll say it was an exciting few years to be there. I got to build the first generation streaming service, launch on the PlayStation 3, and also launch in over 50 countries. And to be honest, by 2012, when Netflix was starting to produce original content, I concluded that all of the interesting technical problems had been solved, and it was time to move on and do other things. So I left for a few years to do some startups, but lo and behold, when I came back in 2018, I realized that I was dead wrong. In those intervening years, Netflix's investment in machine learning had expanded far beyond what you usually think of when you think Netflix plus machine learning, which is the personalized member homepage. In those years, the content buying team's budget had increased to over $12 billion, and they wanted their decisions to be informed by data. In particular, there were machine learning models that helped them program the catalog mix, like series versus films, scripted versus unscripted, and there were other models that helped them predict, hey, if I put a specific title on the service, what might be the audience size? And Netflix had also spun up a studio function that was producing content at a rate that no traditional studio had ever done. They were doing over 100 concurrent productions, so traditional methods were no longer applicable. So machine learning made its way all the way from pre-production, helping sift through all images of scouting locations to try to make that process more efficient, all the way to helping creatives who were doing things like editing sift through large libraries of video content to get exactly the clip they needed at exactly the right time. And there were other facets of machine learning in the Netflix product. Netflix had built a CDN, and there needed to be an algorithm to cache the content on the CDN edge caches, yet another machine learning application. But who was doing all of this machine learning? Well, there was a brand new team of data scientists. And how did they do it? Well, they grabbed a shovel and they did it all from scratch, which meant they had to navigate this complex Netflix ecosystem of infrastructure. And they realized that most of their time was spent not on machine learning modeling, but on infrastructure. And so they practically begged engineering, please form a team to solve our infrastructure problems. And that's when I came back in 2018 to lead machine learning infrastructure. So coming back, I was in an entirely different paradigm. I'll call it ML-powered software. There's several more moving parts that make ML-powered software more complex than traditional software. You still have the valuable system, but now you have a machine learning model that has to plug into that system, and you have data feeding into that model. Oh, and by the way, there's a whole new group of humans that need to interact and deploy with that system. We have a team of data scientists to support. And yet, as an engineering team, we still had the job of making sure that this whole system runs reliably without supervision and produces correct results. Now, the Netflix problem was actually even more complicated than this. We didn't just have to solve this for one ML application. We actually needed to solve this for many, many applications across a variety of business domains and different machine learning modeling techniques. So as an engineering team, we had our hands full. We did not get the budget from Reed Hastings to keep hiring more infrastructure engineers for every data science project. We had to find some really smart ways to leverage the commonalities across all of these products and build a true platform infrastructure that was going to support them. So I want to share with you what were some of the common elements that we saw through the story of one data scientist whose pain really represents kind of this whole picture. So I'm going to introduce Sonia, who is building some sentiment analysis models for the marketing team. Essentially, the marketing team just wants to know, how is Netflix content being perceived on social media? So Sonia sets to work, and at a high level, she needs to build her model, get a data set to feed the model, and then she needs to figure out how to plug the model into that valuable system that the marketing team is using. So she sets to work in a way that data scientists might typically start their work. She wants to prototype something, maybe with a small data set, to see if it's going to work. So she opens up her notebook on her development machine and starts typing away. And then she reaches a point where, hey, this might be something that works, but she needs to, in order to get a model that's going to work, she needs to try many different things, different features, different hyperparameters, possibly even different model architectures. And so she needs to have a history of her experiment. And she comes up with a rudimentary versioning system where essentially she takes a Jupyter notebook that worked, she copies and pastes it into another Jupyter notebook and changes the suffix with a number. So she has her own makeshift versioning system. Works for her, but you might guess that that doesn't necessarily work in a larger organization at scale. So she reaches the point where she has a model in her notebook that she likes, and then she runs into her next problem. It's like, well, how do I get this notebook to run in the marketing system? She has to dive into their code, maybe even write her own Flask app to host this model behind a REST service. This really takes Sonia out of her way, several weeks that she wasn't really planning on. And then to make matters worse, in order to train her model reliably at scale, it's not all going to fit on her development machine with her notebook. So she needs to work with the containerized compute cluster that Netflix provides. It's called Titus, but it's a lot like Kubernetes. So if you know Kubernetes, I'm going to just refer to it as such. So Sonia has to go read the documentation. She has to figure out, how do I write a custom executor and how do I distribute my work on this? Again, more weeks down the drain. But she also needs orchestration because her modeling pipeline has multiple steps, and any of those steps can fail. They can run on different machines. They need some kind of coordination. And so, again, she has to learn how to get this machine learning pipeline mapped to the job scheduler that does that orchestration. As you can imagine, now months have gone by. So a project that Sonia thought was going to take a couple of weeks now has taken 4 months. So stepping back, what we saw after talking to many, many data scientists like Sonia is that they have some common problems that we need to solve. And we can start to conceptualize those by looking at them as pieces of this machine learning stack. All data scientists need data to feed their model and to flow through their modeling pipeline. All of them at one point or another run up with issues where they need access to greater compute resources. They all need some way to orchestrate their pipelines, deal with failures, et cetera. And they need to version those models, deploy them, and of course, at the top of the stack, we have the actual modeling piece, which Sonia thought she was going to be spending her time on, but she didn't get to spend much time. So when we looked at this whole stack, and we looked at the stories of the data scientists, there was really a key observation behind this, which is most of the time that data scientists were spending was at the bottom of the stack, whereas the things they care about are at the top of the stack. We saw this as an opportunity to build infrastructure and remove some of that heavy lifting that data scientists were doing. And that was the essential concept behind Metaflow, which takes all of these layers of the stack and packages them together in a neat abstraction such that the data scientists don't need to worry about the infrastructure. So I'm going to walk you through Metaflow. It's going to be a very brief and incomplete tour, but there's going to be some resources you can look at to learn a lot more. And we're going to look at Metaflow through the lens of this stack. So at its core, Metaflow essentially allows you to specify a pipeline as a DAG, or a directed acyclic graph of computation. And each computation step, as you might expect, takes in some data, performs some computation, and then produces some more data for output. So this is about the simplest flow we can write. It has a start step and an end step. And the way that you specify the start step and end step is actually extending this class called FlowSpec, which provides you with a bunch of Metaflow magic. And that allows you to decorate individual methods with this step decorator to say all the computation happening in that method is actually a node in the DAG. And then you can take the self.next calls here in order to draw the arrows in between the nodes. So with this very simple construct, you can create sort of arbitrarily complex directed acyclic graphs. The other benefit of Metaflow is that it will orchestrate all these steps for you, and you can essentially run this class on your local development machine as if it's just any other Python class. So there's really, it provides kind of some nice abstractions here. So let's look at how Metaflow helps across the stack. And the first thing Sonia needs to do is make sure that her data flows through her pipeline. So Metaflow will automatically take any data that you put into a local class variable and serialize it into an immutable artifact store. And that's a very powerful thing because it eliminates some decisions and some extra work that Sonia would otherwise have to do. Right? She no longer has to decide, well, what format should I serialize this in? Where should I store it? How should I organize it? How do I rehydrate this data? How do I handle the failures? And the other thing it also helps her avoid is worrying about, well, when I am experimenting and there's new data that I want to look at, she doesn't have to remember to go and serialize that data. So she might be adding new model evaluation metrics along the way, and they're automatically handled for her. Moving up the stack, there's also a pretty nice abstraction for running a given step on a containerized compute cluster. So this decorator shows how to use Kubernetes to ask for a large memory instance. You can do the same thing, to ask for CPU or GPU resources. So now all of a sudden, Sonia can essentially treat Kubernetes as a virtually infinite extension of her development machine to provide more resources. So as needed, she can ask for resources for these memory or computationally intensive steps. Metaflow, as I mentioned, provides orchestration built in. It essentially lays out the DAG for you, knows what order the steps should be run in, and then runs them where they need to be run, whether they're in your local environment or on your compute cluster. You can also use Metaflow to map the flow onto your production scheduler using a simple command line. So it can map onto Argo, for example. And then, as I mentioned before, versioning is built into Metaflow, and there's just one more important feature, right, about these local variables that are put into the Metaflow artifact store. They're stored as immutable artifacts and automatically versioned. So every time you run a flow, you get a new unique run ID for that flow. So for that run. So you can say, in the Metaflow client API, you can later retrieve that data and say, for the hello flow, run ID number 10, please get me the value of X at the start step, and you will get the value of 1. You can also say, please get me the value of X at the end step, and you'll get the value of 2. So this lays the foundation for some pretty important capabilities that folks like Sonia need. For example, she can take any given run and tag it, so rather than having to copy and paste her whole notebook, she can kind of keep track of her experiments using tags. And tags can also be used to do things like production deployments, keep track of which version of the model is in production. And then finally, we have deployment. Sonia needs to make sure that she can deploy her model and run it on a schedule. Most models will get trained on some frequency, and so she can provide this metadata to say, hey, scheduler, please run this flow on a nightly basis. And then finally, modeling. This is where Sonia has the maximum degrees of freedom and control without necessarily being constrained to use a particular modeling framework. So at this point, she's using scikit-learn, and she's requesting a conda dependency for a specific version of scikit-learn. That's very important because what we don't want to do is sort of have things happen transparently or unbeknownst to Sonia. We don't want her to worry about, hey, there was a container running that some other engineer was managing that you have no idea about, and the person managing that container updated your version of pandas, and that updated version of pandas then broke your entire flow. So she has some fine-grained control over what modeling frameworks and what versions she uses, and this provides a lot of stability. We talked about the code a lot, and the reality is, though, that the code itself doesn't really provide a lot of value. The code needs to be connected to underlying infrastructure for this whole system to work. And that's really the beauty of Metaflow. It really provides the glue and abstraction for this entire stack of infrastructure so that data scientists don't have to learn about each individual piece. We'll use an AWS deployment as an example. So the artifact store is deployed and works on S3. The compute cluster could either be Kubernetes cluster or AWS batch. Versioning and orchestration are built-in capabilities of Metaflow. And then for deployment, we can go up using Argo or step functions. And then at the modeling layer, we can take advantage of the entire Python machine learning ecosystem. So with infrastructure, we have a pretty powerful setup with Metaflow. Let me take a couple minutes and talk about zooming back out from the individual data scientist to like Netflix as a business. What impact did Metaflow have here? And there were three main concerns. The first was velocity. Data scientists didn't want to spend months deploying their machine learning models. The next one was volume. Netflix was doing more and more machine learning, not less, so we needed to make it easier to do many more applications. And then the third is variety, right? We're deploying machine learning all the way from maybe some simple linear models to some complicated computer vision models for media machine learning. Now, for velocity, we actually had a pretty dramatic result. If we look at this time to production for the models that ended up in production, they got deployed in a week or less, 2/3 of the time. So that made a huge difference for folks like Sonia. And then when it comes to volume, I want to point out this chart is extremely old, so pay more attention to the shape of this curve. We got this hockey stick curve of adoption. This was significant because Netflix doesn't mandate folks to use a given technology. They have choices. And so seeing the choice of Metaflow was really important. So now there's thousands of projects running on Metaflow. I believe there are over 1 billion steps that have been run across all those projects. And at peak, we've been able to run over 10,000 tasks. So the scale is there. Now, when it comes to variety, we didn't actually stop at serving the needs of Netflix. We actually had a hypothesis that if we could create a virtual team of data scientists at many other companies, that they would push Metaflow in directions that Netflix wasn't. So 3 years ago, we open sourced Metaflow. And in those years, we've gained adoption of nearly 2,000 community members who are part of the Slack channel. It's one of the top 10 open source projects that Netflix has produced. I'm proud of this because we're comparing ourselves to famous projects like Chaos Monkey. And we've also now have multiple cloud integrations. Netflix itself is only interested in AWS integrations, but thanks to open sourcing, we have these integrations with Azure and GCP. And in fact, there's a startup called Outer Bounds that 2 ex-Netflix engineers went on to found who worked on Metaflow, and they are focusing on helping other companies adopt Metaflow. I don't work for them, but I think they're great and wanted to give them a shout out here. They have also helped some pretty big named companies adopt Metaflow. So it's a pretty thriving community. So if you want to know more about Metaflow, the project, check out metaflow.org. And if you go to the Outer Bounds website, they also have some really great tutorials as well as access to the Slack channel. My colleague, Ville, he's a founder of Outer Bounds and my former colleague at Netflix, wrote a book called Effective Data Science Infrastructure. He took the concepts that I kind of touched on in this talk into much more depth in this book. So if you want to learn about applying a data science infrastructure at your company, this is definitely the book for you. So we're going to switch gears a bit and talk about the team behind Metaflow. Ville, in fact, is a very friendly person, and on my first day at Netflix in 2018, he greeted me very warmly. Hey, Julie, yesterday we released Metaflow 1.0, and I'm going to give a talk about Metaflow. So he led me into the conference room. It was a bit intimidating. It was a big room with gladiator-style seating, and there were already about 70 people from the data platform in that room. And to be honest, when I sat down, I was expecting to hear a very technical talk, to hear about Metaflow architecture, and maybe some big fancy numbers about what it could do at scale. I had this idea about what makes a successful platform that Ville, I'll say, fundamentally changed my mind about in this talk. He started with the story of the data scientist. And it wasn't unlike the story I just told you about Sonia. And he also talked about how Metaflow made Sonia's life better. So I walked away from that talk realizing that enabling a business to do bigger and better things at higher scale may be a nice side effect of a strong platform. But in essence, the success of a platform is only as far as the superpowers you can give the humans that are using that platform. And I think the idea that Ville was embodying in that talk and a lot of his work was this mindset around customer obsession. And I took that mindset very seriously and built and hired the team around this mindset because honestly, I think it was the single most important factor that led to Metaflow being successful. So I'm going to spend a few minutes talking about what customer obsession in action really looks like. And I'll break it down into two main parts. The first is become an expert in your customer needs. And I say needs because I don't mean what they want or what they say would be a nice idea. Really, you need to be the foremost expert in your customers. First, you got to choose who your customers are. You actually do have a choice. If you think about who your customers are and who they aren't, it'll actually give you a lot better focus. And then you need to spend a lot of time, make it your business to know your customers well. If you do this right, then the next bit of it really feels like magic. It feels like you're equipping your customers with superpowers. And you do this first by taking away their pain. And you can do this now because you're an expert in their experience, you know what their pain is. And once you've done that, you've gained their trust and respect, and they'll start to listen to you. And then you can start to teach them how to avoid pain in the first place, and that really is magic. So how did this play out in Metaflow? Well, the first step was, who are our customers? I'll admit that for Metaflow in particular, this was actually very easy because we had data scientists literally asking for platform support. So we identified our customers as data scientists as well as machine learning engineers. It's not true at all companies, but at Netflix, data scientists were in charge of the end-to-end machine learning lifecycle, so they had to support their models in production as well, so really ML engineering is included. But it was equally important for us to remind ourselves who our customers were not. There was another type of machine learning practitioner at Netflix called algorithm engineers, and they worked on all the personalization algorithms you see in the member homepage. They already had an infrastructure team supporting them, and they were working on the Java stack, which is where the Netflix ecosystem is deployed. So we were just really careful not to focus on their feedback to really inform our strategy. And there were some other data practitioners that we also identified as non-customers. So by doing this, we were able to come up with a strategy that may seem pretty obvious now, but it was actually a bit controversial, right? We had this strategy where we started building infrastructure at the bottom of our stack and worked our way up. But conventional wisdom, from talking to many large tech companies that have ML infrastructure teams, they were actually solving problems at the top of the stack. So they were doing things like, building a generic feature store, building a model registry or training framework. And instead, we focused on some very basic things like, data parallel training, job scheduling, orchestration. So knowing who our customers were kind of gave us that direction and that velocity and that confidence that we were focusing on the right things. And once we identified who our customers were, we now needed to get to know them. And there's a few steps that you need to do to really get to know who your customers are. The first is talk to as many of them as possible in detail about their daily lives. I'll say Ville was quite good at doing this. He really focused in on specific examples as opposed to general statements. So, hey, tell me about the last time that you built a feature engineering pipeline. What tools did you use? What tools did you evaluate? Where did things break down? What workarounds did you employ? Why did they matter? So framing it in terms of the daily life of your customer is extremely important because it avoids things like general statements or non-committal statements like, well, that would be a good idea. There's a really great book called The Mom Test. It's really small, but I linked it up here on the slide. And it really talks about how to have user conversations. So I recommend reading that book. Once we had many, many conversations, patterns began to emerge. So in the case of Sonia and many other data scientists, we saw a huge divide between the development sort of environment and the containerized compute environment. And data scientists were kind of struggling to get between these two. So when we saw that pattern, the next step was not to go build a solution, but rather to pair with data scientists to make them successful. We chose customers who had representative pain of a larger population, and we focused on two things. First, how do we make those customers successful, wildly so? And then second, learning along the way how we need to go about building a solution to their problem. Okay, so why did we bother with this? And the answer is the experiencing self and the remembering self are actually quite different. When you have a conversation with a customer and you ask them about their daily lives, you're activating their remembering self. And that person might forget what all the decision points were along the way, what the pitfalls were that they fell in. They're going to tell you more about the end result. And when we pair with data scientists and help make them successful, we're activating the experiencing self, who is actually going through every step along the way of their data science projects. So we can watch the data scientists experience their pains, and because we're on that project, we are experiencing it ourselves. So it's from that place of experience that we can then start to design a solution. So in Sonia's case and for many others, we saw kind of this whole workflow where they were starting on their local machine, and we wanted to meet them where they are. Let's make sure it's easy to run, Metaflow on your local development machine. But there came a point in time where they needed to tap into this, practically infinite compute resources. So adding this decorator right in line with their workflow made it much easier for them to access those resources. And very crucially, we needed to design this such that we didn't introduce new pain along the process. So for example, asking the user, hey, you should learn more about Kubernetes, you should come up with a YAML file that's going to configure your job. We knew from experience that that would be introducing new pain. So here's where the fun comes in. Now that we have helped solve it for one user, two users, several customers, now we can really feel confident that we have a solution that works. And we want to start teaching the whole user population how to avoid pain. And there's no better way for that teaching to happen than data scientists teaching other data scientists. So organically, we saw that in the machine learning modeling forum that the data scientists held monthly, they started to add slides to their talks about Metaflow and how Metaflow helped them in their projects. So that's the best result you want to see. It doesn't always happen that way. You actually need to do some marketing. But in the case of Metaflow, we were very careful about what we marketed and when we did so, because we wanted to make a guarantee that features that we added to the platform could be supported forever, right? There's nothing like painstakingly building up trust and respect of users only for the users to adopt the features and then immediately things get broken because there's a breaking change, because there's a migration, because of system instability. So we really took seriously that anything we advertise had already been tested and proven, and rigorously so, and that we could be confident that we would support that for all time, essentially. And the other thing that for this particular set of customers is they're not engineers, right? So asking them to do things like migrations wasn't quite reasonable. And there was a couple other modalities where we helped customers avoid pain. We provided a Slack channel. You know, it's kind of the typical support channel, but we really emphasize this idea of fanatical customer support. And the way I could describe that is a helpful, empathetic place where data scientists could ask any questions and feel like they didn't just get an answer to their question, but they got their problem solved. And you know, we got a lot of the typical, technical questions. How do I use this? Oh, this thing went wrong. But something funny started to happen. We started to get questions that were more forward-looking over time. Questions like this example. This is actually in the Metaflow public channel. And the question this person is asking is, okay, well, I'm about to design my flows. Like, what are some best practices for separating out, the ETL portion from the training portion? How do I do that? In this case, Ville actually responded with a couple of helpful articles. But here's an example where we were able to help a customer avoid pain in the first place. One other aspect that I would consider to be part of the product is education. Right? The engineering team took education seriously and didn't just treat it as an afterthought. And there was a few modalities that were supported. The first one is an example on the left from the metaflow.org documentation. And if you go and check out metaflow.org, you'll notice that the titles of these articles are really geared toward the data scientist's journey and what they're trying to accomplish, as opposed to being a list of features. So for example, how do you execute a remote task? Or how do you scale up your system? And then tutorials is also another mechanism, like showing a complete end-to-end example. And we really stress doing that in a fashion that would be both accessible and relatable to real-world problems. So in the middle here, these tutorials are actually some more recent ones from Outer Bounds. They're fantastic. Definitely recommend you check them out. And then within Netflix, we also taught classes. This was a great chance to get data scientists onboarded, but also to have conversations with them coming in. What is their impression of Metaflow, and then what tools they're used to using at other companies. So in some way, that was kind of market research that we did. So stepping way back, this idea of customer obsession and this mindset would be the one thing I would replicate if I were to build a new team that was building a new product, because I do think it's the single biggest reason why Metaflow succeeded. One thing to note about customer obsession is that it's a different way to think about product management. In fact, you're not really thinking about the product much. You're really thinking about the customer and how you can solve their pain. If you do that, the product will follow from that. So I hope that provides you with some takeaways for your projects. I'd be really interested to hear how you're thinking about going about this, so please find me after the talk. I want to give one more plug to the Metaflow resources here, and also want to give a big thank you to Ville, because he let me copy a lot of his slides and illustrations, all of the little wizards. I think they're really great. And then one final plug, which is that I'm looking for my next adventure. So if you're interested in talking to me about machine learning infrastructure, product engineering, come find me after the talk or look at my LinkedIn. And I don't know if I wrapped up early, but if there's time for questions, we're good.
Am I working? Yes. Thank you, Julie. Round of applause, please.
Thank you.
We do have time for questions, and I will run around with a microphone. So hands up if you have a question. Oh, coming this way.
Thank you, Julie. That was a great talk. Would you recommend someone with a smaller team that's just starting out on their machine learning journey implement this now, or is it more for when you're experiencing problems of scale?
That is a fantastic question. And I'd say the hypothesis, which I think has largely become true for Metaflow in the open source ecosystem, is that it actually will help especially companies that don't have the bandwidth or resources to hire their own infrastructure team. And so we've seen Metaflow, being adopted by companies that have just like one or two or a handful of data scientists. So I think it's actually a great place to get started. The other thing that I'll mention here, again, another plug for Out of Bounds, I think they're great. They have a sandbox environment for Metaflow that lets you press a button and essentially it creates all of the infrastructure that you need on AWS. So it's really easy to just give it a try and see if it's going to work for you.
Awesome. Any other questions? Oh, sure. Excellent in the front row.
Thank you. Thanks. I don't know if you can answer this question or not, but I don't know much about ML, but I know it's a bit less algorithmic than some other software. How do you manage testing a product when your models and stuff might have like non-deterministic or unusual outputs?
Yeah, that's a good question. There's a lot of techniques, and I'll say I haven't seen great implementations of that, but generally you do these kind of monitoring, right? I mean, that's kind of the last line of defense, so like monitoring for like data drift. So as you train the model versus when you do scoring or inferencing on the model, there could be sort of drift between those two data sets, and when they get too far apart, you start to run into problems. There's other kind of issues. There's infrastructural issues, there's modeling issues, and so for the infrastructure, generally having a standard paved path kind of makes that a little bit easier. So there's a number of different techniques being used. One thing that I've seen is usually this idea of sort of model quality takes a back seat and isn't necessarily thought of in the beginning. And so I think a lot of us could do better, right, at emphasizing that up front.
Thank you for your question, Shaw. Was there any last questions? Oh, in the middle. How do I get to you?
What was the key metric that defined the success of Metaflow adoption in Netflix?
Yeah. Well, to be honest, like one that I didn't share, it's not a metric, but I actually think that the biggest indicator of success was us getting feedback. We got feedback directly from users saying, oh my gosh, this changed my life. And then I got feedback from other data science leaders who said, hey, this is really having a great impact. So that's the qualitative side. Quantitatively, the ones that I shared earlier in the talk, just seeing, hey, can we shorten the time to production? Are we getting Metaflow adoption? We had an internal dashboard actually that looked up like the directory of employees who were doing data science, kept track of like who was new coming into the organization, and what was the concentration of adoption on any given team. So we could get a much finer granularity view and know, oh, hey, this team isn't using Metaflow. Is it because they don't need it, or is it because they don't know about it? So that kind of helped us, hone in a little bit on, how various teams were using it.